Cams on everyone. Let's start off. Great. So last thing that we did, we started with uniform accelerated motion and we have seen things moving left and right. Today we are going to see things going up and down. So, yep, let's go ahead. Motion in a vertical line. Others do keep your cams on. Now, before jumping into this, we need to define few things. Right? Who is the Zoom user? Okay. So every body on the surface of the Earth is attracted by a Earth generating an acceleration of Getting it? This is also called as acceleration due to gravity. This is what you studied in school. The symbol is small g. Now for Earth, this value is around 9.81 meter per second square. For convenience, we will take g as 10. So if I don't mention anything, take g as 10. Right? And this thing, right, is independent of mass in vacuum. In vacuum, this is independent of mass. Means what? You take a coin, you take a feather, you take an elephant, you take anything, you throw it from a building, they all will have same acceleration. So any body on the Earth's surface will have same acceleration g 9.5. So if you change the planet, for example, if you go to Moon, the value would be 1/6 of the gravity on the Earth. You need not know it. I'm just giving it. For example, if you go to Jupiter, I think this value comes to around 62.1 meter per second square. So 6 times the gravity. So you go to Jupiter and you become suddenly 6 times more heavy. So this g ka value changes from planet to planet. So most of the times we do problems for Earth, but that's how it is. Clear with this. Now in this, there are a few words here. First thing, when you say vertical line, so what is up and down exactly? What is up and what is down? Now, if I ask you what is up, you'll say like this, right? So if you say up and down, so does it mean this way? The person in the North Pole is standing like this. The person in the South Pole is walking with their head. People at the equator are crawling on the floor. Is this how people stay? No, right? So then what is up and what is down? So when you say up and down, it is towards the center of the Earth. So keep this in mind. Quite a useful thing. Later on, when we deal with things, you'll see. When you say down, the meaning is the direction of net force. So when you're standing at the North Pole, this is down. When you're standing at the equator, you stand like this. When you're standing on the South Pole, you stand like this. So the whole concept of up and down Is this so? Down is toward the center of the earth. Up is away from the center of the earth. Clear with this? So keep that thing in mind. When you say up and down, that's what it means. Down means toward the earth, up means away from the center of the earth. Because what is down for you is actually up for the guy at the South Pole, isn't it? The whole thing changes. Now, when we study this also, right? We study under certain assumptions. The first assumption, we neglect any air resistance. Later on, we are going to introduce some air resistance problems also, but not now. We also neglect the variation in gravity. If you actually go away from the Earth, the gravity decreases. Yeah, but most of the times we are just talking about 100, 200 meter, 1 kilometer, 2 kilometers. So you can ignore the change. Third, we neglect the Earth ka rotation and we neglect the Earth ka curvature. You're getting it? So, for example, think about this thing. Let's say we have a building at the equator, okay? So let's say this is east, this is west. So it's a very tall building, maybe let's say 1 2 kilometer tall building. You're standing at the top, I'm standing at the bottom. And you decided to throw a stone on me. Just like that. I gave too many tough questions and you got irritated. So you decided to take a stone and drop it on the teacher. Now the question, if you leave this stone, right, considering Earth ka rotation, let's consider Earth ka rotation is also going on, right? So what will happen to the stone? So options will be, will the stone fall on me? Will the stone fall behind me? Will the stone fall in front of me? What do you guys think? It's a very tall building. I'm at the ground floor. You're on the top floor. Neglect air resistance. We are only considering Earth ka rotation. If you drop a stone from the top, will it fall on me? Will it fall in front of me? Will it fall behind me? So this is east, this side is west. So I'm standing on the east side of the building. It matters. What do you guys think? There's no air resistance. Neglect air resistance, consider Earth ka rotation. Okay, Ahana says behind. What do others think? Think. Everyone should say some answer. Is the teacher safe? Do you think I will let you kill me that easily? So falling on me is not an option. Dekha, you can guess like that. Yeah, let's sound more scientific. So okay, Shrikant also says east, that is in front of me, right, Anish? Okay, let's see. First, let's talk about few things. When you take the earth, and let's say when the building is tall, did you ever notice on a fan, when the fan is rotating, the tip of the fan rotates faster than the points inside, isn't it? That means the person who is standing here is going faster compared to the person standing here. Agreed? So if this is V1 and this is V2, V1 is greater than V2. You guys agree with that? This is one of the problem when you put a very tall building. Because see, this is how it is going. The earth is rotating. So this guy is rotating in a bigger circle. I'm exaggerating the figure. This guy is going in a smaller circle. So in same time, they complete one revolution. So V1 is greater than V2. Is that clear? That means when you throw the stone, now see what happens. The moment you drop the stone, even though it looks like it is at rest, in reality, it has some speed, right? V1. And I have a speed V2. Now, by the time the stone falls down, the stone would have traveled more distance. I would have traveled a less distance, isn't it? With respect to the earth, meaning if I draw the figure, picture ऐसा दिखेगा. I know it's a curvature is there, but if I'm ignoring it, that means this stone will actually come and fall in front of me, isn't it? The stone at the top is going faster than me horizontal direction mein. So by the time it reaches the ground, it would have traveled more distance horizontally compared to me. Is that making sense? The stone will come and fall in front of me. Is the logic making sense? So stone, when you're throwing at the top, with respect to the earth, you are going faster than me. If you neglect the earth ka rotation, what would have happened? If you neglect the earth ka rotation, then both have zero speed, isn't it? The stone will come straight and fall on me. Are you clear with the difference? So earth rotation does matter, right? So that's how you can play around. That's why I said east west bhi matter karega. For example, the same scenario, if I'm standing this way, logic is still the same. This is going this way, I'm going this way. The stone will fall behind me, isn't it? Because front and back is again relative. So yeah, that's how it goes. You know this Pearl Harbor, right? That what happened? So Pearl Harbor, when these Americans were attacking, the Japanese coast, what they did, the Pacific Ocean is pretty large. So Japan was here and US was here. They took their aircraft carriers. Most of them got destroyed. They had only one or two aircraft carriers left. And this is in 1945s, right? So 1930, 940 times. So this aircraft carrier, you know what's an aircraft carrier, right? They have planes on top of it and it's like a moving runway. So these are big. Now, on these aircraft carriers, right, they have fighter planes. These fighter planes are Chotosa planes. They have guns and machine guns. They really don't have missiles and bombs at that time. So with those aeroplanes, right, you really cannot go and destroy anything. You can't just shoot down a factory. So you need to send bombers. Bombers can carry a lot of bombs and you can drop it. But for a bomber to go from a airport, it needs almost a 1 kilometer runway. Now, how do you send a bomber from a aircraft carrier which has barely 250 meters of runway? So they removed a lot of, these things didn't even have machine guns or anything. They just had bombs. And what is the plan? They will take off from the aircraft carrier. They will drop the bombs in Japan and they'll go to China and land. They don't even have fuel to come back. After reaching in China, if they're lucky, somehow allies will catch them and they will survive, or else they will die. It's a suicide mission, basically. Okay, so that was a story there. And the plan was the aircraft carrier will reach a distance of 100, 200 kilometers from the coastline and then they will launch it. Then what happened? As these aircraft carriers were coming, the Japanese ships have spotted the aircraft carriers. Almost, I think, 300, 350 kilometers ahead. Now they didn't have an option. Either they should abort the mission and go back, or they should launch the planes right now. So they decided to launch the planes. And when they did this, what they did? They turned the ships towards US, that is towards the east, and they made the ships go at full speed, and then they launched the planes. So three things are happening here. One, right? Earth rotates from east to west, west to east. The Earth is rotating from west to east. That's why sun rises first in the Japan side. So that means whenever you're sending a plane, you actually add the Earth ka speed also to it. That's why all rockets that you launch are launched from west to east. No one launches in the opposite direction. You get additional speed from the Earth. And second thing, the ships are going also towards US side. So the aeroplane is getting an extra speed because of the ship. Third, the aeroplane ka khud ka speed. You're getting? So they added the three speeds. So you can make the planes, take off easily. So something of that sort. So Earth ka rotation matters, especially when you're launching a drone or when you're launching a missile. If you don't consider Earth ka rotation, right? Let's say you want to bomb Ghatkopar, you will go and bomb Thane. So that kind of errors you get. Anyway, second thing, the curvature of Earth. This is also important. If you look at Earth, right? When you're actually walking straight, if you can actually walk really straight, for every 8 kilometers that you walk, the Earth goes down by 5 meters. So the Earth is actually going down. Earth is not flat. So this is also important. You launch a missile to someone in the 20th floor and you don't consider Earth rotation, the missile will go and hit the 5th floor. So there, gone. So Matters. So when you're sending drones over a large distance or sending a delivery through a drone, these things will matter. The Earth ka curvature. So in Mumbai, right now they made this metro ka tunnel, right? How do you think they build this tunnel? Do you think it's a straight line? The metro ka tunnels are also curved. That is how the tunnels look like. No one builds a straight tunnel. It's a bad idea. You'll come out of the earth if you build a straight tunnel. Anyway, that is a bit about it. And if I had to tell you one more thing, during 1960s, right, Cold War, US and Russia have gone mad and they both started making bigger and bigger nuclear bombs. At some point, US had enough nuclear bombs to destroy the earth 8 times. You can destroy the entire earth 8 times back to back. They had so many bombs. They had just gone that mad, right? And they both were developing bigger and bigger bombs. And after some point, both of them realized it is pointless and they stopped making bigger bombs. You know why? It is because of Earth curvature. Because if you make a really powerful bomb and if you blast it, how does the energy travel? In straight lines. So this energy will simply go into space, isn't it? So if I actually throw a nuclear bomb on Mumbai, Pune is safe. Pune, which is 120 kilometers far, most of the energy, right? If this is Mumbai and this is Pune, most of the energy will go above the sky of Pune. So nothing happens to the Pune city. They don't even notice it. You're getting it? So making a more powerful nuclear bomb is waste of money and waste of time. Like, so they stopped making more powerful nuclear bombs. Instead, they did multi-vehicle entry thing. So you launch a nuclear missile, it goes into there, it splits into 7 nuclear missiles, it hits 7 different cities. This is better, right? So if you want to destroy stuff, humans are experts in it. We will do all nonsense things to destroy anything. Anyway, so that is how Earth ka curvature stopped the nuclear arms race in making bigger bombs. There. So those are the few assumptions we have. So keep this in mind. We neglect air resistance, variation in gravity, Earth rotation, and curvature of Earth. Now, let's see a bit of a theory there. So yeah, for most of the problems, we'll assume it is flat. So consider a particle projected vertically with speed u. So let's say the particle is projected with u. It goes up. Technically, it comes back on the same line, but for you to understand, I'll put it little to the side. Let this be acceleration ay is equal to g. So ay means acceleration in y direction. When your particle goes up at the highest point, momentarily it will come to rest. So at the highest point, it will stop for a moment and then it will turn back. So this is called Hmax. So what is Hmax? This is the maximum height from point of projection. U subscript y. So this is your initial vertical velocity. So u means initial velocity, y meaning vertical direction or y direction. If I write ux meaning initial horizontal velocity. So up is y-axis, right and left is x-axis. Ay is acceleration in vertical direction. So these symbols will be useful. Every time it won't be g, right? Something changes, we know how to adjust it. Perfect. Remember, we know only three equations. V is equal to u plus at, s is ut plus half at square, and v square minus u square is 2as. Because g is constant, I can use them. So at the maximum height, the vertical component of velocity becomes 0. So before turning back, you have to stop for a moment. So using the equation, vy square, v square minus u square is 2as. Velocity is 0. This is u square. 2, gravity is minus g. Remember, up is positive, down is negative. Signs will matter. And this is Hmax. So Hmax is given by u square by 2g. But a better formula would be this. H max is U vertical square by 2A vertical, the magnitude. Again, remember, this is valid only if AY is constant. Later on, we will see what happens if AY is not constant. We have to integrate. There, in case you know this, it is fine. If you don't know, you can note it down. That is how you get the formula for maximum height. All clear with this? Next thing. Time of ascent. TA. This is the time taken to reach H max. We are using the formula V is equal to U plus AT. Highest point velocity is 0. This is U minus G, and this is time of ascent. We get time of ascent is equal to U by G. Again, a better formula would be Uy by Ay. Because tomorrow they will say the particle is thrown on Jupiter, so then it will not be G, right? It will be something else. So then you put Ay there. Time of flight, TF. This is the time taken to reach the point of projection. Or you can say time taken to reach the ground. Or the flat surface, however you want to call. Now in our case, when you throw it here, you come back to the point of projection. So displacement is 0 because you came back to the same point. We'll use S is equal to UT plus half AT square. I am sure you have seen this kind of stuff in school. 0, this is U, time of flight, minus half G time of flight square. We get time of flight is equal to 2U by G. Also can be written as 2UY by AY. But be careful, this formula is valid only if you come back to the same level of projection. Meaning if you do these cases, right? If you're throwing stones from a building, you cannot use it. So if you throw a stone here, this goes up and comes like this. Or if you're throwing a stone down, it comes like this. So it's not valid. So don't use this formula if you're throwing from buildings. For that, we have to do something else. So you should come back to the same level of projection and this formula is valid. Clear with this? Next thing. Time of descent. This is the time taken to reach ground from H max. So you can do like this. So time of flight is nothing but time of ascent plus time of descent. So from here we get time of descent is U by G. Now be careful here. This is valid only again if you come back to the same level. Because if you don't come back to the same level, time of flight ka formula itself is wrong. This is 2u by g, this is u by g plus time. There. So these are our main formulas there. All clear with this? And just to summarize the formulas again, so listen carefully. Let's say particle is projected with u, it goes up and comes down. Let's say the particle is at a certain height y, and at this point, let the speed be vy. And let this initial speed be uy. Acceleration ay is z. So this is what happens to your formulas, everyone. Vy is equal to uy plus ay t. So you just put y everywhere, indicating vertical direction. So this will be Vy is equal to Uy, Ay is minus G. Remember, up positive, down negative. That's your formula there. Sy is equal to Uyt plus half Ayt square. I just put everywhere subscript y and the formula looks same. Sy is the y coordinate. This is Uy time minus half Gt square. So every time they won't ask you Hmax and time of flight. They can ask you somewhere in the middle also. So just remember that the three formulas are valid. You always come back to that. So y is the height from the point of projection. By square uy square is equal to 2ay sy. This would be Vy square minus 2uy square is equal to minus 2gy. Or I can write like this. There, did you see how the three formulas changed? You have just written everything in y direction. Hmax is u square by 2g. Time of flight is 2u by g. Time of descent is u by g. And time of ascent is u by g. These are valid for same level. They're all the formulas you need. I'm just putting at one place. And this is important. You understand this, the next part, projectile, right? This is the basis for this. And what if A is not constant? If Ay is not constant, then yeah, you go back to your regular calculus. Vy will be dy by dt. We will do problems on that also. Ay will be dvy by dt or vy dvy by dy. There, if A is not constant, you go back to your integration. You can put on the things in case you don't know any particular result there, but let's go ahead. All clear with the stuff. Yeah, great. Let's see a question. We have a particle projected with 20 meters per second. So this thing goes up and comes down. Remember, every time I show you like this, but in reality, it is going up and coming down on the same line. You won't see anything, so I'm doing it this way. And be careful, huh? If someone asks you what is the value of g, g is 10 only. Acceleration is minus g. I hope you're getting it. G is a number. G is not negative. Ay is minus g. Find Hmax, find time of flight, find time of ascent. Yeah, just formula substitution. Find time and speed when it reaches h max by 2. This is all just so that you get used to the formulas. Distance traveled in 3/4 of time of light. Let's get these three questions. The first one is easy. Get B and C. Give me those answers. First one, kuch nahi hai. You have to just substitute the formulas. H max, time of flight, time of ascent. Second question, time and speed when it reaches half of H max. And distance traveled in 3/4 of time flight. Yeah. Like I said, give me answers for B and C. Everyone should try. Any confusion, anything you're not clear, please ask me. You just have to use the three formulas. V is U plus AT, S is UT plus half AT square, V square minus U square is 2AS. नहीं Shreya. We are finding for B, right? No. I didn't ask you time for H max. Time for half of H max. Get this, get this. You should get this. Okay, Dave. That's fine. Dave, I want B and C answers. Yeah, Ahana, you get two answers. Okay, let's see the first one. First one was straightforward, right? H max, U square by 2G. U is 20, G is 10, that's 20 meters. Time of flight 2U by G, 4 seconds. Time of ascent U by G, 2 seconds. Yeah, that's all formula there. I hope there is no issue with this. Second question, you are asking time and speed when it reaches h max by 2. Let's get the data first. What is your speed? 20 meters per second. What is your acceleration? Minus 10. What is your displacement or y coordinate? You said half of h max. What is half of h max? 10 meters. What do you want to find? Time. I don't know this. What else you want to find? Speed. I don't know this. Great. I can use the formula v is equal to u plus at. I don't know time, so I'll use v square minus u square is equal to 2as. V square, 20 square, 2 minus 10, s is equal to 10. So v is equal to 10 root 2 meters per second. That is your speed, everyone. Right? Now, you want to find the time. I can actually use this velocity to get time also, but let me do this. This is ut plus half at square. Technically speaking, this is plus or minus because it can be going up or coming down. But I asked you for speed, so it won't matter. S is this is 20 time t minus half g 10 t square. You get a quadratic equation, everyone. T square minus 4t plus 2 is equal to 0. You solve this, you end up with t is equal to 2 plus or minus root 2. Both are right. The question comes, why are you getting two answers? Yeah, if you remember, we discussed this in quadratic beginning. The reason you're getting two answers is because you said find the time to reach 10 meters. You didn't tell which 10 meters. The particle will cross 10 meters two times, once here and once here, while going up and while coming down. So here time will be 2 plus root 2 because it takes more time to reach there. Here it will be 2 minus root 2. Is that clear, everyone, why you get two answers? You cross 10 meters one while going up and 10 meters while coming down. So there are two answers. Yeah. Clear with this? So there nothing big deal. You just need to know your formulas, put there and get it. What about the distance? Right, Sumana, we have one answer. Distance is a good one. That could be a decent mains or a CET level question. Yeah, right, Prisha. You have two answers. Anyone else? What is our distance? Right, Shlok. Yeah, Neha, Hana. Check your answer again. Neha, Anish. Okay, let's see. So you're saying 3/4 of the time of flight. That is 3 seconds. Okay. If I use the formula S is equal to UT plus half AT square, S is 20 into 3 plus half A is minus 10 into 3 square. This would be 15 meters. Be careful. This is a displacement. This is not a distance. I didn't ask you for a displacement. Now, if you look at the motion of this particle, when you projected with U, it went up, it came back. Now, clearly, we know the time of ascent is 2 seconds here, meaning in 2 seconds you reach top. In 3 seconds, you must have already coming down. So T is equal to 3 is here. And what did you get? You got displacement. You're saying this is 15 meters. I hope you're getting it. Displacement doesn't care how much you went up. So how much did you actually travel? First you went till H max, which is 20 meters. Then while coming down, you traveled 5 meters. Therefore, distance is 25 meters. I told you multiple times. You hear the word distance, have some fear. All clear with this? The distance traveled, you have to take the entire path. Any doubts on this? Clear, na, Rohit? Ananya, Manav, Shlok, Tanmay, Yukti, Soumya. Clear, everyone? Great. Let's see the next one. We have a particle projected with speed u. It goes up, comes back, hits the floor. The speed becomes u by 2. It goes up, comes back. The speed becomes u by 4. And so on. The speed keeps becoming half. Again, technically, all this happened on the same line. I'm putting it to the side. You have done this thing in remember that where infinite GP particle is projected with speed u vertically. After hitting the floor, it bounces back with half the speed. Find the total distance, total time, and the average speed. After colliding with the floor, it bounces back with half the speed. So find the total distance traveled, total time till it stops, and average speed. In the exam, I will ask you average speed directly. In case someone forgot about it, I'll give you the formula for this. If you have infinite terms, this is the sequence A plus A into R power 1 plus A into R square, and so on till infinity. The sum of all these terms is given by A by 1 minus R. This is the formula for R less than 1. This is an infinite GP. If someone doesn't remember this, where did we do this? There. We did here, page 23, basic math. We did a similar question here. I said 3/5. So you should refer this. Page 23, basic math. There, let's get this thing. Get me the average speed. I'm more interested on that. Because if you know total distance and divide by total time, you will get average speed. So if you ask you average speed, you have to calculate everything. The particle is projected with speed u, gravity is present. Every time it hits the floor, speed becomes half. So this will just keep bouncing, 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 and eventually it stops. Find the total distance, total time, and the average speed. Rohit. Think about it. If I throw you with speed u, how can you get answer greater than u? It's like, think about this. In a classroom, people got different marks. Someone got 30, someone got 40, someone got 100, someone got 80. Can the average be greater than 100? It's like, your teacher telling you to, telling in the class, everyone in the class should get more than average. You see the contradiction with that statement? Everyone in the class should get more than average. Nee, Anish, that's wrong. Prisha got it. Sumana got it. We have two answers. Later on, we are going to see. I'm going to ask you to draw a velocity time graph for this. That would be fun. That was the actual question. Drawing a velocity and time graph, velocity displacement graph. You can draw different graphs for this. Try to draw a VT graph and see. That would be fun. Okay, Ahana got it. Karthik got it. Yeah, I think most of you are getting it. Okay, should I show you? See. So when you projected with speed u, you will go up. You will come down. Okay. Let this be h. And let the time be t. So what is h? H is equal to u square by 2g. And this is proportional to u square. Means every time your speed becomes half, u square becomes 1/4. Your time of flight is 2u by g, proportional to u. So second time, when your speed becomes half, you will go less height. How much will you go? You will go only h by 4. And how much time it will take? T by 2. Next time when the speed becomes u by 4, how much height you will go? So every time it becomes 1/4, 1/4. So it will become h by 16 and the time becomes t by 4 and so on. Is this making sense, everyone? So what is the total distance? Now remember, total distance you have to count up and down. So that will be 2 times h, going up, coming down, h and h. 2 times h by 4, 2 times h by 16, and so on till infinity. Take out 2h common. You will get 1 plus 1 by 4 plus 1 by 4 square, so on till infinity. That's your sequence. We can clearly see A is 1 and R is 1 by 4. So the sum of the infinite terms, the formula is A by 1 minus R. That would be 1 by 1 minus 4, so that would be 4 by 3. So the total distance traveled will be 8h by 3. This is your total distance. Similarly, when you take the total time, it will be t plus t by 2 plus t by 4 and so on till infinity. We can clearly see the sequence here, 1 plus half plus 1 by 2 square and so on till infinity. A is 1 and R is half. If you apply the formula, you get 2. This is 2t. So this is the total time. What do you want to find? Average speed. So once you got this stuff, average speed is total distance by total time. So distance is 8h by 3. The time is 2t. So that would be 8 by 3. And what is h? U square by 2g. What is time? 2 into 2u by g. So 8 will cancel, g will cancel, you end up with u by 3. All clear with this? That is how they mix up that infinite GP and everything. Any doubts on this? All clear with the steps. So main thing, in case you don't know this formula, that would have been a little difficult, but yeah, you can refer that. We have done this in basic math. Any doubts on this? Clear, na? Tanmay, Shlok?
Sir, I didn't understand how we got distance equal to 8h by g.
8h by g. 8h by 3, that
8h by
is.
g.
So this is 4 by 3 and this is 2h. So multiply.
Yes, sir, but like h is directly proportional to u square, right?
Yeah.
So, and
And u is
distance
becoming
equal.
half every time. U is becoming half. So what happens? Half square is 1/4. Half power 4 is 1 by 16. So 1 by 4 keeps coming out, isn't it?
Oh, yes, sir, but why is it 2h?
Because you have to count going up and down distance, h plus h.
Oh, okay, okay.
Right? When you come down, this is also h. While going up, this is also h. So distance may have to count both. Okay?
Yes, sir, got it.
Yeah. Let's see a better one. Let's say we have a weird planet. This weird planet, the gravity changes for every 10 meters. So for the first 10 meters, the gravity is g. For the next 10 meters, the gravity is g by 2. Gravity is g, and the gravity becomes c by 2, and the gravity becomes g by 4, then the gravity becomes g by 8, and so on. So for every 10 meters, the gravity becomes half. And this is happening till infinity. Now, why is it happening? Don't worry about it. It is happening. The gravity becomes half for every 10 meters. G ka value is 10 meters per second. And now you threw a particle with speed u vertically. The first question, if u is 15 meters per second, find h max. No, be careful. You cannot use the formula directly because the gravity is changing. That formula is valid only when g is constant. The second thing, find u minimum. So with what speed should you throw so that it never comes back. Meaning there is a particular speed. If you throw with that particular speed, because the gravity is continuously decreasing, this particle will go off to infinity. There's a name for this. It's also called as escape velocity. So if you throw something with an escape velocity, means you will leave the planet. Are you getting the question here? If you throw with 15 meters per second, find h max. Second thing, with the there's a minimum speed which you should throw. And because the gravity is continuously decreasing, there is a chance this might never come back only. So what is that minimum speed so that the particle escapes to infinity? This is also called as escape velocity. For Earth, the escape velocity is around 11.2 kilometers per second, neglecting air resistance. If there's no air resistance and if you kick something with 11.2 kilometers per second, that's really fast, you will leave the Earth. Let's get the first one. Any answers? You can play around with the question, like find the minimum speed required to reach a height of 80 meters. I can ask things like that also. If you want to reach 100 meters, what is the minimum speed? So on. So, but anyway, let's get the first part. I think, yeah, Anish, you got the first part right. Right, Rohit got the first part. Prisha got the first part. Get the second one now. Think how will you approach? I can't use u square by 2g directly because g is changing. But let me give you an idea, okay? Do you agree g is constant in this region? Means I can apply the formula for each region, right? So let the speed be v1 when you reach here. Let the speed be v2 when you reach here. So apply the formula here, apply the formula here. Now see if you can do that. Right, Prashant? Now, what will you do if I ask you something like this? Find the speed to reach 100 meters or nth section. Can you find a velocity in terms of that? Find the speed required to reach nth section. You actually get a geometric progression. You should know the formula for that. Nay, Rohit, that is wrong. Karthik got the first part right. Ahana got both of it. Okay, let's see the first part. See. So as this is going, let the speed be v1 here. So I can apply the formula here for the first section. Apply the formula v square minus u square. So final speed is v1 square, initial speed is u square. 2, gravity is minus g, and this is 10. Right? So this would give you v1 square. U is how much? U is 15. That's 225. That is 25. So v1 is equal to 5 meter per second. Great. Meaning you did cross the first section. For the second section. Now, before going to the second section, we can check actually. Are you even crossing 10 meters or not? So if I use the Hmax formula, see, in the beginning, if I use Hmax formula, I'll get 15 square by 20, which is definitely greater than 10. So you're crossing the first section. You can't use the formula. But when I apply the formula for the second section, remember the formula Vy square by 2Ay. Now Vy is how much? 5, that is V1 square. By 2, gravity has become G by 2. This is what I said. The formula, right? Write like this, Vy square by 2Ay. This is 25 by 10, that is 2.5 meters. So clear, right? This particle is not crossing the second section. It goes till here and turns back. So it is traveling only 2.5 meters in the second section. So therefore, Hmax is you cross the entire first section and then you do 2.5 meters at 12.5. That's making sense? Yeah, it would have been difficult, right? If it was 10th or 11th section, then this would have been a mess. Yeah, but we can do that even for an nth section also. All clear with this? The second part. This is an interesting one. Now, see, you're going to infinity, means you're not going to come back, right? So let the velocity be v1, let the velocity be v2, let the velocity be v3, and so on. Now, if you write the equations in the first section, we get v1 square. So v1 is the final speed, u is the initial speed. 2 minus g, 10. For the second section, v2 is the final speed, v1 becomes the initial speed. So the final speed of one section becomes the initial speed for the next section. Is that making sense? This would be 2 into minus g by 2, the gravity has become half, and this is 10. v3 square minus v2 square is equal to 2 into minus g by 2 square into 10, and so on. If you write this, you get vn square minus vn minus 1 square will be 2 into minus g by 2 power n minus 1 into 10. How do I know it is 2 power n minus 1? Look at this. When this is v1, this is 2 power 1. When it is v2, it is 2 square. So n minus 1, it should be 2 power n minus 1. I hope you can see the sequence. This is a very important model. Huh? These kind of functions, right? If you see, there is something interesting. If you add all of them, you will notice this v1 will cancel, this v2 will cancel, this v3 will cancel, this vn square and this will cancel. All this will cancel, and you'll be left out with vn square minus u square is equal to minus 20g, and take out the common 1 plus half plus 1 by 2 square, so on till 1 by 2 power n minus 1. These kind of functions are called telescopic functions. So the final value of one thing becomes initial value for the next thing, and so on. These are called telescopic functions. And when you add all of them, everything else gets cancelled in the middle. You will be left with the initial and the final. Any doubt so far? All clear with these equations? What I did? I cannot write the equation directly from starting to final, but I can write for each section. And then, since you want to go to infinity, n becomes infinity. Now, let me write in the next page. N will go to infinity. So this will become v infinity square minus u square is minus 200, 1 plus 1 by 2 plus 1 by 2 square. This also will go to infinity. Now it becomes an infinite GP. So if you're doing for nth section, we can use this formula directly. So this will be v infinity square is equal to u square minus 200, and that would be 2. The sum of this entire sequence is 2. 1 by 1 minus half. So we get v infinity square is u square minus 400. This should be greater than or equal to 0. Because when you want to reach infinity, your speed can be, this will give you u square is greater than 400. This will give you u must be greater than or equal to 20 meters per second. So this is saying any speed greater than 20, you're going to escape to infinity. Therefore, the minimum speed is 20. All clear the steps? So the main idea here is to figure out that I have to write the equation for each section separately. Any doubts on that? Once you write for each section, you will realize when you add them, they'll get cancelled out. Figuring out is the second part. And once you got that, then it is over. It is all math after that. Since you're going to infinity, you'll do for n sections and you're done. All clear with this? There, you can see how infinite GP we are using it. Take a break. Come back by 9:40. We'll continue from here. Any doubts so far? Anything you're not clear? Go, get away from the screen. Come back by 9:40. We'll continue from here then. Not any doubts. Anything, anyone is confused? Chalo, come back by 9:40 then. Yeah, let's start off. Let's see one more. So the particle is projected with speed u. It goes up and comes down. Right, and we observe distance traveled in fifth second and the sixth second. Remember, fifth and sixth are not 5 and 6. Is same. Find u and h max. And if you got u, you will get h max anyway. So find h max. Gravity g is there, 10. It's a decent question, like the proper means one. The particle is projected with some speed. How much we don't know, but it is observed it is traveling same distance in the fifth second and the sixth second. This much you know. Using this information, find the maximum height of the particle. नहीं युक्ति. नहीं, I think that is right. Right युक्ति. Right, Karthik. Anyone else? Right, Anish. So what is the idea there? Now let's think about this, okay? Now see, there are only three possible scenarios here. Let's say if this scenario had happened while the particle is going up, what would have happened? As we go up, speed will decrease. Means you will travel lesser and lesser distances. Suppose this scenario, if they're equal, if it happened while going up, this is what you would notice. Remember, fifth second meaning t is equal to 4 to t is equal to 5 is the fifth second. T is equal to 5 to t is equal to 6 is the sixth second. So we can clearly see here, this is S5, this is S6. As you're going up, speed decreases, so S5 will be greater than S6. So yeah, this can't happen. Second possibility, maybe this happened while coming down. Means you already went up, you took a turn, and then you're coming down. Now, if this is the scenario, again, same story. If this is T4, this is T5, now you're going faster and faster. In this scenario, S6 will be greater than S5 because the speed increases. So this is also not possible. Now, if you think about it, there's only one option left. That means you should not be going up, you should not be coming down. So this is possible only if you're traveling t is equal to 4 to t is equal to 5 while going up. and 5 to t is equal to 6 while coming down. Means 4 and 6 and 5, right? They're symmetrical there. So this is possible only if 4 to 5 and 5 to 6 are exactly on either side of the H max. Is that making sense? You can't go up, you can't come down. So what's left? Go up and come down. So this is the only option left. So that means indirectly they're giving you time of ascent. So here you get S5 is equal to S6. So time of ascent is 5 seconds. Time of ascent is U by G. So speed is 50 meters per second. So H max is U square by 2G. That's 125 meters. Making sense? Because think about a fourth possibility. Either you're going up or you're coming down, or maybe you're going part of the motion up and part of the motion down. Since you're traveling equal, they should have been symmetrical on either side. So 5 must be the midpoint. So yeah, kind of. We guessed it at that point, but yeah. All clear with this? You can figure out like that. Or you can do the 10th second stuff and everything, but uh, because 4 to 5 is S5, 5 to 6 is S6. That means 5 is the highest point, isn't it? So when you went from 4 to 5 and 5 to 6, so 5 is the highest point because both sides are symmetrical. Clear, no? No? Yeah. Yeah, that is one thing. Next thing. This is a standard model. We got a building, height h. In the first scenario, you took a particle, you released it from rest. So this particle will fall straight and hit the floor. The second case, the particle is projected with speed u up. It goes up and then falls down. Third case, you throwed it down with speed u, so it just comes straight down. Right? So the time of flight is t1. Here the time of flight is t2. Time of flight is t3. Find t1, t2, t3 and find relation between them. The relation between them is an important question. You have to remember that result. But anyway, first let's get t1, t2, t3. Find t1, t2, t3. The building is same. First case, you dropped it. Second case, you throwed it up with you. Third case, you throwed it down with you. Find the times in the three cases. Now you can't use the formula 2u by g because that formula was derived when you threw it from the ground and you came back to the ground. That formula is not valid when you throw from buildings. Let's get this. Again, remember, your three equations are still valid. V is u plus at, S is ut plus half at square, V square minus u square is 2s. If something changes, you don't know what to do, you always go back to the basics. Yep, right, Prashant. Right, Yukti. Let's see. Now, before doing the problem, right, let me ask you some things, okay? Let's see. Whenever you throw something, the starting point is the initial, okay? So if you're dropping from here and you're going down, this is your displacement, everyone, the green line. So in the first case, what is the displacement? What is the displacement here? S is equal to minus h. Remember, the signs are important because it is coming down, displacement is minus h. What is your speed? 0. What is your acceleration? Minus g. What you want to find? Time. So we'll use the equation S is equal to ut plus half at square. That's it. That's what you should ask. What data do I have and what do I need to keep? So minus h, this is 0. This is minus half g t1 square. So we get t1 is equal to root 2h by g. Great. Look at the second one. Again, what is the displacement? You are initially here, finally you're reaching the ground. This is the displacement, again minus h. It doesn't matter whether you leave it, you throw it, you do anything, the displacement is always minus h. Because displacement will see only one thing. Where are you initially? Where are you finally? I don't care whether you went up or came down. What is your initial ui? Plus u because you're going up. What is your acceleration? Minus g. Substitute in the formula. Minus h is equal to ut minus half g t2 square. You get a quadratic equation. Half g t2 square minus u t2 minus h is equal to 0. Solve this. We get t2 is equal to u plus or minus. We'll not take the minus. That root is anyway positive. U square plus 2gh by g. Again, don't remember the result. Understand how to derive it. Look at the third one. You are throwing down. The what is the displacement? Displacement is still minus h. This is the thing most people get confused. So be careful. It doesn't matter how you throw from a building. It only is initial, final. Displacement is always minus h. What is the velocity though? Minus u. What is the acceleration? Minus g. So if you notice carefully, the only thing which is changing is your velocity. This one term which I'm marking in red box, that is messing up the whole answer. So here it would be same thing, minus h, minus u t3, minus half g t3 square. Solve this, you get the same answer. You'll get minus u plus root over u square plus 2gh by g. Check. Are you clear with this? So instead of remembering the formula, remember how to use the result. Like, you know the displacement, you know the velocity, you know acceleration. Dump it there and you're done. Got this? Next thing, we want to find the relation. Take T2 and T3. If you take T2 and T3, you'll get a U plus root over U square plus 2GH by G minus U plus root over U square plus 2GH by G. You can clearly see this thing is looking like A plus B and A minus B. This would be minus U square plus 2GH by G square. This comes out to be 2H by G, which is nothing but T1 square. There, this is a result which you should definitely remember. Direct CET equation or a bits level equation. You will not have time to derive this whole thing in the exam. Right? T1 is the time when it is released. And if you notice something, this relation does not depend on height of the building or speed of the particle. You throw with whatever speed you want, up and down, same speed, any height of the building, this ratio will always remain, this relation will be always same. T1 square is T2, T3. All clear with this? Any doubts on this? There, literally, if you see, right, I covered all the cases in a building. Can you throw any other way in a building? Either you leave it, or you throw down, or you throw up. That's it. Let's do one more on this so that you just get used to the formula. Let's say we got a building of 60 meters. The particle is projected with u is equal to 20 meters per second. It goes up and comes down. Find time of flight and the speed when it reaches the ground. The direct formula substitution. See, I might be asking different questions, but end of the day, every time I come back to the same three equations. That's how you should think. Don't think like, yaar, har ek problem alag lag raha hai. All problems, end of the day, the main crux is the three equations only. You just have to understand how to use. Get this. This is it's a decent one. 2 root 3, 40. I don't know, 6 and 40. That looks right. 6 and 40, 6 and 80. We have a lot of 6 and 40s though. Others who got something else, I don't know. Let's see. Okay, ask yourself, where are you starting? You're starting at this point. This is your starting. Where is the ending point down? So you're going down. This is your displacement. How much? Minus 60. So be careful with the signs. S is not the distance. I don't care whether you throw up or you throw down. Where are you initially? Where are you finally? That is the only question you need to ask. S is minus 60. U is plus 20. Up is positive, down is negative. A is minus 10. You want to find time. You want to find speed. Great. See which equation you need to use. S is ut plus half at square. S is minus 60. U is 20. T minus half G 10 T square. This will be T square minus 4T plus 12. Minus 12, I guess. Then get the roots for this. 4 plus or minus B square. 16 plus 48 by 2. That is 64. 8 will come. 8 plus 4, 12. 6 seconds. You got a good number. You want to find the speed, I can use v square minus u square is equal to 2s, or you can use v is equal to u plus 80, v square, u square is 20 square. 2, acceleration is minus 10, displacement is minus 60. Most people goof up that minus sign for displacement. Be careful. You mess up one minus sign, whole thing will go for a toss. That's 400, 1200, 1600. Yeah, 6 and 40. Check. There's nothing there. You just have to apply the formula and you'll get it there. All clear with this? Great. Any doubts on this? Let's see one more. Now, let's say we have some air resistance. So we have a particle projected with 20 meters per second. So this thing goes up and comes down, and let's say there is air resistance. I will make your life, we'll keep it a little simple. Gravity G is still there. This air resistance, right? It does this thing. The particle is projected vertically with 20 meters per second. So the air resistance offers an additional 2 meters per second square opposite to velocity. The wordings are important. Now, exam they will expect you to figure it out. Offers an additional acceleration 2 meter per second square opposite to velocity. Like that's what air resistance does, right? It'll oppose you always opposite to velocity. You go front, it'll push you back. You go back, it'll push you forward. Right? So find the time of flight. I'll give you a little more context. And speed when it reaches the ground. You won't come back with the same speed. To give a little more context, listen. When you're going up, the particle ka velocity is upward. So what will happen? The gravity G will be downward. That is always down. G is 10. Your air resistance is also downward, which is extra 2. So when the particle is going up V, so the net gravity, right? So we can call this thing G effective is 12. See, the particle really does not know what is gravity, what is air resistance and all. The particle will simply think, oh, the gravity has become 12 meters per second square. That's what it will think. We call this thing effective gravity. I hope you're getting the meaning of this. Because of air resistance, the particle will start thinking, oh, G became 12. Usko aisa lag raha hai. Same thing while coming down. This is what happens with parachutes. You have already gone up and you took a turn and you're traveling down. Your gravity is still down. The gravity doesn't care how you go. But now your air resistance is opposite to velocity, that is 2. So now G effective will become 8. Are you guys clear with the question? So while going up, it behaves the gravity is 12. While coming down, it behaves the gravity is 8. That is the meaning of it offers an additional 2 meters per second square opposite to velocity. Whichever way you're traveling, usko opposite mein, I will generate extra 2. Now, using this information and the data, find me the time of flight and find the speed when you reach the ground. Okay, let's see. I don't remember the answer. Prisha, you can't come back with 20, right?
So can you show the next slide?
Yeah. Okay, you got the velocity. I don't remember the answer, so but give it a try 1 or 2 minutes. I'll show. Even I have to do and check. But Yeah, but I think you will get an answer in roots. You won't get an integer or a fraction or something. You will get a root में आएगा answer. इतना तो पता है. Yukti might be right. I'm not sure. But others keep trying. It's a good one. In real life, the gravity, right? This acceleration will also be weird. It will not be constant. That also will change with some velocity. That also we'll do later on in the class. But for now, let's take this constant and let's figure it out. टाइम 10 नहीं रे अनिश भाई बोल रहा हूँ ना इतना अच्छा टाइम नहीं आएगा इतना पता है मुझे आंसर आई डोंट रिमेम्बर कार्तिक गॉट समथिंग मोर वियर्ड 240 by 144 10 root 6 I don't know yeah you got something else Yukti also got something else Yukti got root 2 by 3 5 by 3 Prisha got root 800 by I hope you guys are finding time of flight time to go up and time to come down so there'll be actually two values you have to add. So yeah, check. I'll give you another minute. Yukti, let's see your answer. That looks wrong, Ray Yukti. एक बार check करो ना Yukti. The time of flight is not matching with what I did. नहीं आना. You guys are goofing up somewhere. You cannot use the time of descent का formula here. I hope you guys are not doing that. Time of descent का formula you can't use. Why? I'll tell you. In time of descent, what was u? U is the speed when you throw it down. In time of descent, you also came down with u, isn't it? But are you coming down with u again? No, na. You can't use that thing. Time of descent, this should be the speed which it comes back. So how do you handle this? Okay, so I got something that looks right. I'm not sure. Okay, should I show? Okay, let's do step by step. Let's see the part when you throw it up. That was the easiest one. You throw it up, speed was 20 meters per second. You're going here, the gravity, I'll just call it a G effective, was 12. So you stop here, V is equal to 0. Remember, this is your H max. So time of ascent is U vertical by A vertical. U vertical is 20, A vertical is 12. That is 5 by 3 seconds. So there is no problem here. While you're going up, the equations are good. H max, this is the reason I was writing the formulas like this, uy square to ay and all. Because हर बार gravity g नहीं होगा. Uy will be 20 square by 2 and ay is 12. That's 400 by 2, 200 by 12, 100 by 6, 50 by 3. Great. Now we need this information. Now second part of the problem. Now this problem has become the particle is at rest. Now the question behaves as if there is a building of 50 by 3. Isn't that how the question looks? There is a building of 50 by 3 and someone released it from rest. And the gravity is 8 meters per second. So this question looks like a particle thrown from a building. At least that's how you can think of. You know the formula. But okay, you don't know the formula, I will derive it. What is the formula? S is equal to ut plus half at square. What is the displacement? Minus 50 by 3. What is the initial velocity? 0. What is the gravity? 8. This is the time square. This is your time of descent. How much is this? 4 25 by 6. 5 by root 6. That's your time of descent. Now, what is the total time of flight? The total time of flight is the time to go up, 5 by 3, time to come back, 5 by root 6. Please see where you guys messed up. The mistake, I think, I don't know. Maybe you guys are doing u by g for coming back also. You can't do that. That won't work here because you're not coming back with the same speed. Let's see with what speed you're coming back actually. What speed you're coming back? V square minus u square is equal to 2as. V square, initial speed is 0. Remember, I have changed the problem. This is my initial speed now, V is 0. Forget about going up. We are doing going up and coming down separately. This is 2. Acceleration is minus 8. Displacement is minus 50 by 3. So, yeah, that's not 20. It's not so clear. That's definitely not 20. So V square would be, how much is that? 400 by 3? 16.5. 4,000 by 3. Wait. 800 by 3. That would be 20 root over 2 by 3. This is the final speed. See, if there is an air resistance, the system will lose energy. So you can't go and come back with the same speed. Is this clear, everyone? Yeah, I think speed you got right, Prisha. Time also, maybe you forgot to keep the root. I think you got time of descent. Something messed up, so check it out. Yukti, you got the same 5 by 2 root 2 by. Yeah, you are right. You're right, Yukti. You got it. My mistake. But all clear with this? Other than that one point, right? The additional acceleration 2 meter per second. If you actually see, isn't the question simply one is going up, one is coming down? Looks manageable, right? So you just have to be careful with the words, nothing much. Clear with this? Great. Let's see one more. So we have a hot air balloon. And you're standing inside. So this hot air balloon goes up with a constant acceleration. (2 meters per second square). So initially it was at rest. The balloon is going up with an acceleration 2 meters per second square. Now, some people, right, they get confused like, sir, but what is gravity doing? So you need to understand when I say 2 meters per second square, this is inclusive of gravity. Meaning if the gravity had not been there, you would have gone with 12. You're getting it? So 12 minus 10, the balance is 2. So this is the net effect of including gravity. So whenever someone says it is going up with 2, 3, it is understood. It is including gravity. So don't get confused there. So after fighting the gravity, whatever is remaining is taking you with 2. This is including gravity. That is, if gravity was missing, it would have gone with 12. That is, you can think of. Anyways, so the balloon started going up. After some time, around t is equal to 10 seconds, You dropped a coin from the balloon. A coin is released gently, you just tossed it. On the balloon at t is equal to 10 seconds. Find the time taken for the coin to reach the ground after releasing. There, let's get this. This is another standard model. This kind of questions have come in mains and bits before. Think for a minute, then I'll tell you something and I'll give you a little more time after that if you want. Yeah, right, Prisha. So, nahi yukti. No, Karthik. Just to give a little context, okay? Listen to this. Let's say you're going in a bus with a speed of 50 kilometers per hour. If you jump from the bus, gently, if you just jump from the bus, will you gently land on the ground? No, right? So keep that in mind. So whenever you throw something from a moving vehicle, you will have the same speed as the vehicle. That is what happens when you get down from a running train. If a train is moving and if you suddenly jump and if you just stop there, you're going to roll on the floor. You guys know how to get down from a running vehicle, right? Which you're not supposed to do, but still. A train is coming on a platform, you have to get down very fast. So what you do, once you get down, you don't stop. You also run with the train for a little while and then you slow down. Because if you just jump and just stand there, what happens, the moment you jump from a train and you just stand there, your legs will touch the ground, so they will come to rest, but your upper body is still going with velocity. You will roll on the floor. Bad idea. So that's how you get down from a running train. Let's see, at 4 root 6, 300. I don't think I'll get a good number. Okay, let's see the data here. So we have our balloon here. Initially speed is 0, acceleration is 2 meter per second square. Great. So after 10 seconds, you will be somewhere here. What is this distance? S is equal to ut plus half at square. Initial velocity is 0, acceleration 2, time is 10 square. So the balloon is at a height of 100 meters. Great. What is the velocity of the balloon? V is equal to u plus at. U is 0, A is 20 meters per second. So the moment when you throw the coin, your speed of the balloon is 20 meters per second. So that is the thing. The particle speed is not 0. A particle released from a vehicle will have the same speed as a vehicle. Right, has same velocity. So if you're going in a bus and if you throw a water packet on someone, you think you're throwing water, but the other guy feels like it's someone slapped him. So it does hurt. That is the main thing. So even though the word is gentle, it means nothing. So the whole question has become like this. So the question has transformed into a building problem. So we got a building of height 100 meters. So that's how you should always think. Okay, this scenario is looking like what? And someone is throwing a coin with 20 meters per second. Indirectly, I'm asking you, find time of flight. Isn't this the question? So once you leave the balloon, now you don't have any contact with the balloon. Getting it? The acceleration becomes g. After leaving the balloon, the coin falls with acceleration g. So as long as you are in the balloon, you'll have an acceleration. Once you're out, you're gone. Did you ever notice this? You have a mosquito in a train. It is biting you and doing everything. Once it goes out of the window, it just gets dragged away. As long as it is in the train, it will have the same speed and acceleration as the train. Coin has acceleration. I'll ask you a scenario. See, let's say you're in a Mumbai local train. You're inside. And for some reason, right, you decided to start hopping inside the train. You're jumping up, down, up, down, up, down. You're getting how? You're just jumping at the same place, up and down. So you're jumping into the air, then you're falling down, jumping up and falling down. And you noticed when you do this, and your friend is also there, and he or she is watching you doing some weird stuff. And they notice you're going back continuously. Every time you jump up and down, you're coming back. The train is going forward. Using this information, can you tell me whether the train is speeding up or speeding down? Is the train accelerating or decelerating? Again, listen to the question. The train is going front. Your friend is sitting there. So they are not moving in the train. But you decided to do some jumping. You're doing up and down, up and down. And he observed you are getting closer to your friend. Next time you're here, next time you're here. Is the train accelerating or decelerating? Yeah, I think most of you are getting it. But got the scenario? No. So think of like this. Let's say train ka speed is some 30. When you're standing in the train, your speed is also 30. The moment you jump, the train is speeding up. Iska speed ho gaya 32. So when you jump up, you're still going with 30, but the floor is going with 32, isn't it? So when you land back, you will land behind. Is that making sense? So that is how you can actually figure out whether the train is accelerating or not inside the train. Anyway, so then we use the formula S is equal to ut plus half at square. Substitute the values here, minus 100. This is 20t. This is minus half g 10t square. You will get a quadratic equation, t square minus 4t minus 20 is equal to 0. T is equal to 4 plus root over 16 plus 8t by 2. Yeah, that's 2 plus, how much is that? 96. 96 is 16, 6, 2 root 6. Check. All clear with this? So there, these are the 2 points. So when you are in the balloon, you will go with the balloon. So once you leave the particle, you will have the same velocity as the balloon there. All clear with this? Then we saw there are a few other problems there. And before going ahead, let me show you something. I'll post this in the group also anyway, but
This
I
is
don't know if you have
NASA's
seen
space
this.
power facility near Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft in
So
conditions of outer space.
this thing was a nuclear facility of US, and after the Cold War got over and all, NASA took it over and they used this facility, right, to test spaceships and everything. Once they build the spaceship, you want to see how they work in vacuum. So this is a huge vacuum chamber. You can remove all the air from inside. So I'll put it in the group. You can watch it aram se, but let me show you the main crux. So there, this is the experiment. They took a bowling ball and they took feathers.
He took a heavy object and a light one, and drop them at the same time to see which
So
fell
there is an air
fastest.
resistance and you're going to drop them. You know what happens. Ball will fall first. The feathers will come down aram se. This is what you would normally see in real life.
Now in this case, the feathers fell to the ground at a slower rate than the bowling ball because of air resistance. So in order to see the true nature of gravity, we have to remove the air.
So if you remove the air thing, so you seal it up, you pump all the air out. And this takes time and a lot of things. The walls have to be really thick. Huh? The atmosphere literally will crush the whole thing.
3 hours to pump out.
It takes 3 hours to remove all the air.
But once it's
So they did all that. They removed all the air.
Ten,
There. Now they kept the same bowling ball and the feather. They're dropping it.
7, 6, 5, 4. Cameras on. 2, 1. Release.
There, look at this. They are always side by side. See, they're always side by side. We know it will fall, but looking at this something else. They reach the same time.
Exactly.
They came down exactly.
Look at this. Everyone in the room knows they'll fall at the same time, but seeing it is a different story. We're like, oh shit, seriously, this is coming down at the same time.
Exactly.
Exactly. Feathers don't move. Nothing. Look at that.
That's just brilliant.
There. Watch the video again. I'll post it in the group. You can check it out. So yeah, this is the cycloid thing.
Sometimes knowing a
Remember
certain
that
piece
we
of
did that thing
information
distance travel.
is often
This is
less
how the
useful
particles
than
go.
being able to figure something out. Here's an example. If you take a point on the edge of a wheel and trace out its path as the wheel rolls, you'll draw out a curve called a cycloid. A cycloid might look like a slice taken out of a circle, but it is a unique kind of curve. So how can we work with this curve and figure out a tweaked way to understand
So
something
you can
complicated?
check out this also.
What would it be like to travel to Mars to get us really going by modifying the
This is
gravity?
also the gravity
If
free
I were
space.
really
That's
going to
again
Mars,
I'm
I
sure
would
you know this
experience
guy.
not 30 seconds of microgravity as I do in this plane, but
There is a
months of it.
service, you know, they
And
have a
then when I
plane,
got
0G
to Mars,
gravity.
this
Expensive,
would be the gravity on the
but you get an
surface.
experience of gravity free space and everything. Let's see one more weird video.
What's up, guys? Everything Alpha Pro here, and today we're going to be testing
This guy
this AK-70.
So remember the question we did? How many planks are needed to stop the bullet? So this guy does a situation. How many iPhones are required to stop a AK-47 bullet?
4 Russian C6 plus.
So
Who knows? But
there, they
let's
brought
see
some
what happens.
iPhones.
And how many iPhones would you have in your pocket in order to save your life? So here I've got a steel core bullet. This can travel up to 2,900.
You can't do this kind of stuff in
This
India.
thing will totally obliterate these guys.
So unfortunately, I couldn't afford a $100,000
Can't afford all
slow-motion
iPhones, it
camera.
seems.
I worked with what I had, and these are these phones that we
should,
know.
right?
Let's see how
So now
many
you're going
iPhones
to
it
fire.
takes to stop a bullet. All right, now here's the mom kit in order for them to save your life. Answer to that clears the first 4 and landed in the screen of the 5th one, which is
Stop at the
also
5th one,
the
so-
iPhone 6 clone. I didn't really expect the bullet to make it so far, but it absolutely shredded through them. Now, this is a
And if you notice something here, look at this interestingly. Yeah? When the bullet entered, the hole was small. As it is traveling, the hole became big. So this actually happens with bullets. You know, when the bullet is traveling, it creates a cone of air in front of it like a shockwave. So once it enters the body, right, in the front, it will be a small hole. But when it comes out of the body, you get a bigger hole there. So it basically, it expands inside. So makes it dangerous. Anyway, so there's some of the stuff there. I'll post them. You can check it out. So Okay, so that would be the last one for the day. Next class, when we catch up, we will see a few more on this. We will also do, some problems based on what happens if G is not constant. So we will bring your integration and differentiation back again